The learning objective for today's lesson is to be able to find probabilities for normal distributions and find data values given probabilities. Every normally distributed random variable has a unique mean and standard deviation, which affects the position and shape of the curve. So if you look at this diagram here, the random variable V is equal to the volume of Coke in a Coke can. And you can see that the data is clustered very close to this mean here. So the data isn't as spread out. And we'd expect to see this from a process which is automated via computers. However, if we look at the random variable t, which is equal to the times taken for the runners in the London Marathon, we can see we have a flatter curve. So the data is more spread out. And again, we'd expect to see this with elite runners running quick times over here, and maybe first time slow runners having a slower time over here. Now, as a result, there are infinitely many normal probability distributions. Fortunately, they can all be related to one distribution known as the standard normal distribution. Now, the standard normal distribution is a normal distribution of z values with a mean of 0 and a standard deviation of 1. Now, the corresponding z values for a given data value x can always be found using the formula. And remember, z values represent the number of standard deviations away from the mean. So if you look at this diagram here, we can see that the distribution is centered about the mean 0. And these values that we have here represent the standard deviations, or the z values. So you can see 2 is 2 standard deviations above the mean, and -3 is 3 standard deviations below the mean. So the total area under the curve is equal to 1 or 100%. Almost all of the area is between z equals -3 and z equals 3, so that's within 3 standard deviations of the mean. And the distribution is symmetric. The mean is 0 and the standard deviation is 1. And the curve approaches but never touches the x-axis. And we've seen this from the tail ends of this distribution. Now, once you found the corresponding z value using this formula for a given data value x, we can then work out probabilities using this table of z values. Now, there is a condition. We can only use this table of z values directly if we have this scenario here, where z is a positive number and we want to work out the area of it being less than this value of z. So let's look at an example. The probability of z being less than 1.42, let's draw ourselves a diagram. So the mean is 0 because this is a standard normal distribution, and you know that because we are dealing with z values. Okay, so now 1.42 lies above 0 over here somewhere. We draw a line and we're interested in the area to the left of the curve. Okay, so you can see this scenario matches what we have here. So we can work out the probability over here directly using this table. Okay, so how do we use the table? So 1.42 is our z value, so we read this up to 1 decimal place, or the first decimal place, so 1.4. So go along your first column, or go down your first column to 1.4, and you have some possible probabilities. So this is the probability for it being less than 1.40, 1.41, 1.42. So this is the one we're looking for. Just to double check this, okay, we can see that the second decimal place has a digit of 2. So along the top here, we want the second decimal place to have a digit of 2. So we keep going until we get to that. Okay, so this is the one we're looking for, and this is indeed the probability that we want. So the probability of z being less than 1.42 is equal to 0.9222. Okay, now in our next slide, I'll show you how to use your Casio calculator to work out all of these scenarios. Okay, so it'll save you some time during the exam, but it will require some practice using your Casio calculators. And I would always still recommend to use diagrams so that you can formulate your strategy. So what we want to do now is to set up your Casio calculator so that it's in statistics mode. Okay, so obviously your calculator needs to be turned on. You click on where it says mode, so this button here, press this. Okay, and you get a series of options, 8 options. We're interested in option 3 where it says stat. So select 3. Now you get another series of options which we won't be using. So we're not interested in any of these. So just click on AC. And you can see at the top here, it says stat. So that means your calculator is now in statistics mode. Now once your calculator is set into statistics mode, as you can see here, When we want to work out the area to the left of the z value, okay, so we have situations like this. So whether it's positive or negative, we want the area to the left of the z value because these correspond to the probabilities. Then we use the p function on the calculator. Now to select the p function, we click on Shift 1, and then from these 6 options, we select option number 5. So go ahead and click on 5, and we're interested in the p function. Okay, so the area to the left of the z value. So go ahead and click on option 1. Okay, so now we want the probability that z is less than 1.21. So go ahead and type in 1.21, close brackets, and then the probability that z is less than 1.21 would be equal to 0.88686. Okay, so now we want the probability of z being less than negative 0.545. So we'll delete this and type in negative 0.45. So you can see we're still using the p function. Okay, and when we press equals, we get the probability 0.32636. Now, if you want the area to the right of the z value, so a scenario like this, whether it's positive or negative, the area is to the right of the z value. Remember, these are corresponding to the probabilities that they're greater than these z values. Then we use the r function. Now, to select the r function, we go back onto Shift 1. We select option 5 again. Okay, and now we're interested in the third option here, the r function. So go ahead and click 3. Okay, so now we want the probability that z is more than 1.67. So go ahead and type in 1.67, close the bracket, and then press equals, and we get the probability 0.04746. Okay, and now if we want the probability that z is more than negative 2.35, so we'll use this replay button. We'll go ahead and delete what's in the bracket there and replace this with negative 2.35. So the probability that z is more than negative 2.35 is equal to 0.99061. Now, if you want to work out the area outside of the two z values, so we have this scenario, we have one area to the left and one area to the right, then we need to use the p and r function together. So for what we have here, this area is to the left of this z value. So we need to use the p function for this value here, negative 1.12. Plus, over here, we have the area to the right. So we need to use the r function for 2.01. Now we need to just go ahead and type this into our calculator. So the first one is the p function. So we click on Shift 1, option number 5, option 1 for the p function. So go ahead and click on 1. Okay, and then we type in negative 1.12, close brackets, plus, and now we want the r function. So again, we'll click on Shift and 1, option 5. And then because we want the r function, this is option 3. So we click on 3. Okay, and then we just need to type in 2.01, close bracket, so that the probability would be equal to 0.153576. Now for the final one, if we want to work out the area in between two z values, okay, so we have this scenario, so the area in between these two z values, negative 1.35 and 0.45, we need to use the q function. Okay, so we need to use the q function for negative 1.35, so we need to type in this into our calculator, plus, and we need to use the q function for 0.45, and then type this into our calculator. Now to select the q function in your calculator, click on Shift 1, option 5 for distributions, okay, option 2 for the q function, Okay, and then type in your numbers. So we have negative 1.35, close brackets, plus, and then we need to use the Q function again. So we'll go ahead and select Shift, 1 again, Option 5, and then Option 2 for the Q function. Okay, and then type in 0.45, and that will give us the probability 0.58513.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Example 3. The average number of phone calls received by a customer service representative each day during a 30-day month was 105 with a standard deviation of 12. Find the number of days with fewer than 110 phone calls and assume that the number of calls is normally distributed. So we'll go ahead and make a note of the mean, which is 105, and the standard deviation, which is 12. Okay, and the data value we're interested in is 110 phone calls. So we need to find the corresponding Z value using this formula. So substitute X equals 110, the mean and the standard deviation into this formula, and we get the following. And when we calculate this, we get approximately 0.42, which is our corresponding Z value for this given data value 110. Okay, so now let's see what type of probabilities we need to work out. So we want fewer than 110 phone calls. So the corresponding probability would be the probability Z is less than 0.42. Okay, so let's go ahead and draw ourselves a diagram. Okay, so we have a standard normal distribution because we're dealing with Z values. Okay, with the mean 0 at the center. So 0.42 is the Z value, which is located around here. We draw a line upwards, and we want fewer than or less than 0.42. So this is to the left of this Z value. So we're dealing with the P function on the calculator. So if we type that in, okay, we get the probability of Z being less than 0.42 as being equal to 0.66276. Okay, and we want to know the number of days with fewer than 110 phone calls. So with this probability, we then need to multiply this with 30, okay, to give us what we have over here. Therefore, there were approximately 20 days with fewer than 110 phone calls. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Example 4. The scores for the entrance exam for a college's mathematics department is normally distributed with mean 65 and standard deviation 8. Part A. If Fatima wants to be in the top 20%, what score must she get? Now in example 3, we were given a data value of X, then we found the corresponding Z value, and then from this we calculated the probabilities. In this question, we don't have the data value X, nor the Z value. What we have is this percentage. Now percentages, probabilities and proportions all amount to the same value, which is the corresponding area under the normal curve. So we'll reverse the process. So given this information, we'll find the Z value and then find the corresponding data value X. Now previously we've used calculators to use this Z value and work out the probabilities. However, when we reverse this process to go from probabilities and find the Z value, we can't use the calculator, so we have to use the table of Z values for this question. Now I'll begin by drawing a standard normal distribution, okay, which is centered at the mean 0. We want the top 20%, which is at the upper end of the normal distribution. So we want this area here, which is equal to 0.2 as a decimal. So we want to use this value to find the corresponding Z value. However, to use the table of Z values, we want the area to the left of this Z value. And we know that the total area under the curve is equal to 1. So if this is 0.2 on the right hand side, on the left hand side the area must be equal to 0.8. So we can use this probability of 0.8 to calculate this Z value using this table. Now we have to be careful because this is a probability, not a Z value. So we're looking for in this table where does the probabilities equal to 0.8. Okay, so be careful not to confuse it with this Z value here. That's not what we're looking for. We're looking for this probability within the probability section in your table of values. Now, when you look, you'll find that this value 0.8 doesn't exist on your table. It's not given. However, if you look closely, you'll find that 0.8 actually lies between these two probabilities. Okay, and these two have corresponding Z values of 0.84 and 0.85. So which of these two Z values do we want? Well, let's go back to the probabilities. What we want to ask now is which of these two probabilities is closest to 0.8? Okay, well, we can subtract these two from 0.8 to give us these values. Now, because this is smaller, this tells me 0.7995 is closer to 0.8. So that tells me we want to use this corresponding Z value for this question. So now that we've found the corresponding Z value of 0.84, we can substitute these three values into this formula like so, and then we solve for this data value x. So we begin by multiplying both sides by 8 to give us the following. Add 65 to both sides, and we've solved for the data value x. So therefore, Fatima needs a score of at least 72 to be in the top 20%. Part B. Fatima expects to earn a grade in the middle 90% of the distribution. What range of scores fall in this category? Now, similar to Part A, we draw ourselves a standard normal distribution which is centered at the mean 0. We want the middle 90% represented as an area. So we draw a line to the right of the mean, and then this distance from the mean, we want the same distance to the left of the mean. Okay, so this area now represents 90% or 0.9 as a decimal. Now, because they're the same distance away from the mean, that means their corresponding Z values will be the same, except one will be positive and one will be negative. And that's good because once we know one Z value, we can find the other by changing signs. Now, we want to use this Z value here. And to use this, and to use the table of Z values, we want the area to the left of this Z value. So that includes this area that I've highlighted in yellow. Okay. Now, if this middle that we have in blue represents 90%, that means there's 10% left over. And that 10% has to be shared equally between these two tail ends. So half of 10% would give you 5%, which is going to be equal to 0.05 as a decimal. So now that we have these two areas, we add these two values together, and we know that the total area to the left of this Z value is equal to 0.95. Now we can use 0.95 to find the corresponding positive Z value here using this table of Z values. So we're looking at the probability section here, and we want to know where is 0.95. Well, you'll find it's not given in this table of values. Okay. However, if we look closely enough, we can see 0.95 lies between these two probabilities, and the corresponding Z values for these two are 1.64 and 1.65. Now, which of these two should we select? Well, we go back to the probabilities and ask the question, which of these two is closest to 0.95? Well, we can subtract these two from 0.95 to work out the differences, and we can see actually these two probabilities are the exact same distance away from 0.95. And that tells us 0.95 is actually in the middle of these two. So if it's in the middle of these two, that means the Z value we're looking for is exactly in the middle of these two Z values. So we add these two Z values together and we divide it by 2 to give us 1.645. So now we have the positive Z value, we need to find out the negative value, and we simply do that by changing the sign. So we have negative 1.645. So now we have the two corresponding Z values for this middle 90%. And we want to find the two corresponding data values for x. So we'll begin by substituting this value, the mean and the standard deviation, into the formula to give us the following. Then we solve for this data value x by multiplying firstly by 8, and then adding 65 to both sides to give us this data value which corresponds to this Z value. And we'll do the same on this side. So we'll substitute this value, the mean and the standard deviation, into this formula to give us the following, and then we solve for this data value x. So we'll begin by multiplying both sides by 8, and then we'll add 65 to both sides, and then we have the two corresponding data values that we wanted. So therefore, Fatima expects to score between 52 and 78. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.